Section 12.2, Chords and Arcs. A central angle of a circle is an angle whose vertex is at the center of the circle. In circle B, I have angle ABC that is a central angle. I know that because the vertex of angle ABC is at the center of the circle. If I would add up all the angles of the central angles of the circle, their sum would equal 360 degrees. In the first diagram, I have a central angle BPA. Points B and A are on the circle, and they form what we call in geometry an arc. An arc is part of a circle, which is identified in the first diagram as red. We have a couple of different types of arcs. First, a minor arc. A minor arc is smaller than a semicircle. The second diagram demonstrates a semicircle. It is formed by a diameter in the circle. And a semicircle would be half the measure of the central angles of a circle, therefore 180 degrees. The minor arc is identified by the points on the circle, here BA or AB, and I know this is an arc identified by the symbol above the 2 points. Minor arcs are identified by at least 2 points and can be identified with 3 points depending on how many central angles and arcs I have in the diagram. A major arc is greater than a semicircle, therefore it has to be greater than 180 degrees and must be identified with 3 points on the circle. Here I have arc BCA and arc ACB. When I identify the arc on the circle, I must go in the order of the points in my notation. Therefore I have arc BCA or ACB. These are both the same arc. A semicircle is half the circle, and in this diagram, as mentioned before, I have 2 semicircles. Here I have CBA, which we know is 180 degrees, and I have a semicircle which is CDA, which is also 180 degrees. And the sum of those two would be, of course, the sum of the central angles of my circle, which would be 360. When we measure an arc, we're going to measure it in terms of degrees. And a measure of an arc equals the measure of its central angle. And the measure of a major arc is equal to 360 degrees minus the measure of its related arc. In this diagram, I have a semicircle. It is formed by the diameter CA. Therefore, the measure of CBA, which is the semicircle, has to equal 180 degrees. Also, the semicircle CDA is also 180 degrees. On my next diagram, I have arc BA, or also arc AB. They are the same arc. And I have angle BPA. The measure of angle BPA is 85 degrees. Therefore, the measure of its intercepted arc is 85 degrees. Next, I want to find the measure of arc BCA or ACB. If I look in the diagram, BCA and ACB are the same arc, and since I know that is greater than 180 degrees, it is a major arc. To find the measure of a major arc, I just take 360 minus the measure of its related arc, which is 85 degrees. Therefore, the measure of arc BCA or ACB is equal to 275 degrees. Early in the book, we discussed segments, and in the segments, we know that we have a segment addition postulate. Similar to that, we have an arc addition postulate. The measure of the arc formed by the 2 adjacent arcs is the sum of the measures of the 2 arcs. For example, in the diagram, I have 2 central angles, CPB and BPA. The measure of those angles respectively are 65 degrees and 70 degrees. Since these 2 arcs, CB and BC, are adjacent, and I know that because adjacent arcs are arcs in the same circle that have exactly 1 point in common. Here, that would be point B. When I know this is true, I can use the arc addition postulate. The measure of arc ABC, here, ABC, has to equal the measure of arc CB plus arc BA. And to perform this, all I do is take the measure of the central angle, and I know that that is equal to the measure of its intercepted arc. Therefore, the measure of arc CB is equal to 65 degrees, plus the measure of arc BA, which is 70 degrees, and I find their sum, which is 135 degrees, which is the measure of arc ABC. And this still is a minor arc because it is not greater than 180 degrees. Let's look at some examples. Here they want me to determine if the arc is major, minor, or a semicircle. Here I have arc DC. DC on the diagram is here, and I know that that is less than 180 degrees, therefore arc DC is minor. Next I have arc BAE. BAE, even though this is identified by 3 points on the circle, I cannot assume that that is a major arc. I have to take a look at the arc on the circle itself. BAE is less than 180 degrees, therefore it is a minor arc. Arc BAD. BAD. Notice this is greater than 180 degrees because I have the diameter AD that creates a semicircle, and BAD is greater than a semicircle. Therefore, this is a major arc. Arc CBE. CBE is formed by the diameter CE, and I know a diameter separates the circle into two semicircles. Therefore, arc CBE is a semicircle. And I know that has to equal 180 degrees. Next, I have arc CBD. And that is greater than 180 degrees. Therefore, I know this has to be a major arc. In this example, they want me to find the measure of each arc or angle in circle P. The easiest way to answer the questions related to this diagram is to find all the measure of the arcs and angles that I can prior to looking at their questions. Therefore, if I go to the diagram, I can identify the measure of arcs and angles. For example, here I have arc BA, which is 30 degrees. I know the measure of an arc is equal to the measure of its central angle. That's also true. If I know the arc, then the angle must equal the same as that arc. Therefore, if the arc BA is 30 degrees, angle APB, the central angle, must also be 30 degrees. That's similar to knowing arc CD is 70. Therefore, I know this measure of the central angle related to that arc, CPD, is also 70. In the diagram, I know AD is a diameter. Therefore, that forms a semicircle, ABD, or ACD. I know the measure of a semicircle is 180 degrees. Arc ABD is formed by 3 angles, and I know 2 of those measures, 30 and 70. Therefore, I can find the measure of arc BC by taking 180 minus 30 plus 70. 30 plus 70 is 100. 180 minus 100 leaves me the measure of arc BC to equal 80 degrees. Therefore, I know the measure of angle BPC is 80 degrees. Recall from previous sections, I know that vertical angles are congruent. Here, angle APE and angle CPD are vertical angles. Therefore, I know they're congruent. Since this angle is 70 degrees, because the arc is 70 degrees, I know this angle is 70 degrees. And that makes arc AE equal to 70 degrees. Now, I've identified AD as a diameter, and I know that a diameter is 180 degrees. Arc AE and ED are adjacent. And I know by the arc addition postulate, since this arc DEA is 180, that I can determine arc ED by subtracting 70 from 180. Therefore, this makes ED equal to 110 degrees. Now that we've identified the measure of the arcs and angles, we can go back and answer the questions that are being asked. They want the measure of arc BED. Here I have BED. I know that AD is a diameter, therefore DEA is 180, and that means I need to add another 30 degrees on for BED, therefore 180, and 30 is going to give me 210 degrees. The measure of arc ABC, here ABC, is the sum of arc AB and BC. Therefore, 80 plus 30 is 110 degrees. And we can perform that operation because of the arc addition postulate, similar to measure of arc BED. The measure of arc AE. The measure of arc AE was determined from the measure of arc CD because of vertical angles being congruent. Therefore, the measure of arc AE is 70 degrees. The measure of arc CDE, here, CDE, is made up of two adjacent arcs by the arc addition postulate. 110 and 70 makes this a semicircle, which is 180 degrees. Measure of arc DCE, DCE, is the sum of all the arcs except for arc ED. Therefore, I can subtract the measure of 360 minus 110, its related arc. Therefore, the major arc, DCE, is equal to 360 minus 110, and that would equal 250 degrees. The measure of arc BC, BC, is 80 degrees. On the next three examples, they want me to find the measure of angles. Of course, we know that angles and arcs have equal measures. So I have the measure of angle APE. APE is 70 degrees by vertical angles, and also the measure of arc CD originally. The measure of angle APC. APC. That is the measure of two angles, APB and CPB, and I know the measure of arc BC is 80, therefore its central angle is 80, and I know that angle APC now equals 110. The measure of angle APD, APD, is a straight line, therefore I know that that is 180 degrees. Now you can see that finding the measure of the arcs and angles inside of the diagram makes it easy to find the solutions to the questions.